Hello, this is Professor Iris Miano. I am making a lecture video for Math 50. This is day 2, section R2. So we're going to continue reviewing exponents and order of operations. So here we go. Let's go ahead and define a few things, starting with the natural numbers. So the natural numbers are the numbers that you naturally count when you first learn to start counting, which will be the set of numbers. Oops, hold on, let's add some notes. Starting at 1, going to 2, 3, 4, 5, and so on and so forth, off to positive infinity. So this is just a little bit of set notation indicating the natural numbers. Real numbers, on the other hand, are, you can't really represent that very well with the set, the curly bracket stuff. So we're going to say all numbers that you can think of. Went outside the lines a little bit. Furthermore, if we want to expand this idea of real numbers, then we want to say that it is fractions, right? Irrational numbers, decimals, but also the integers, and so on and so forth. ETC, I'll say. Okay, great. Now let's have another definition in regard to natural numbers. If n is a natural number, there's a little bit of a typo there. No pluralization there. And a is a real number, then the idea is that, just a moment. Sorry about the pause there, I just had to answer my phone, but let's get back to business. Excuse me, if we want to introduce this exponential notation, we will have a as the base. So I'll go ahead and label that as the base. Let's get a different color going here. And that's the number being repeated. And it could be any real number, but the exponent is going to be a natural number. So 1, 2, 3, 4, 5, one of those numbers. We're going to leave 0 out of it for now. So this will be the exponent. And the idea is that using exponential notation, we can have this expanded as a times dot dot dot. We're not sure how many times we can have this repeated factor of a, right? It's going to be repeated n times. And depending on the values of a and n, that'll give us an actual standard form of the, or standard value that I'll put over here. Value. Great. It can be evaluated is basically the idea here. So for the next example, we're just going to identify the base and the exponent and then evaluate the expression. All right, so for the first one, we have 3 to the 4th power. The 3 is going to be the base. The exponent is the 4. And if we wanted to expand that out, it would look like this. 3 times 3 times 3 times 3. The exponent is always telling you how many times you multiply out the base in a string product, product being multiplication, okay? So that'll give us 3 times 3 is 9 over here. Another 3 times 3 gives us another 9. If you multiply all 4 of those 3's, you'll get 81. Okay? Let me go ahead and, for funsies, let's box that up. Okay, and back to blue. Moving on to the next one, 1.5 to the fifth power will be 1.5 times 1.5 times 1.5 times 1.5 times 1.5. Cute. Or 1.2 rather. I said 1.5, I meant 1.2, and luckily I drew the correct term there, or correct factor, that is. All right, so you multiply them all together, and oh, sorry, let's go ahead and determine what the base is. That's going to be the 1.2, and the exponent is a 5. Now here you can rely on your calculator in order to determine this value. So 1.2 to the fifth power. So depending on what kind of calculator you're using, I can give a little bit more of a demonstration of this during lecture or during the lecture discussion if you want. So if you put this into your calculator though, you should get 2.48832. And really, you should rely on your calculator in order to perform this operation. It's not something you necessarily want to be doing by hand. It would take a long time. It's kind of not worth your time. Moving on to the next one, we have a base of -5 and an exponent of 2 there. Now notice that this negative base, the negative sign is inside some parentheses. That means that the negative sign is associated with the base. Moving over to the next example, just to the right of it, notice that there are no parentheses. And in this case, you would say that the base is 5, exponent is still 2. Now why is that? Because when there's a negative sign in front of your exponential expression, that means that with the absence of parentheses, no parentheses over here, that means that negative sign is acting like a factor of -1 in front of the 5 squared, whereas here the negative sign is part of the base itself as being indicated by the presence of the parentheses. Okay, so here on this, going back to this first example to the left in this row, we have -5 times -5, and that's going to give us a positive 25, right? But on the other hand, when we're going to the other example, how does that differ over here? Well, here only the 5 is having imposed on it this exponent of 2. So really it's like saying 5 times 5 is happening, that's the 5 squared, and then we are just simply negating it. That negative sign is not part of the base, so it does not get repeated in the product here. So that'll give us a final answer of -25. Does everyone see the distinction here? And if not, we could talk a little bit more about it in the Zoom class meeting. Moving on to this next example. We have a base of 2/3 and an exponent of 3. That'll be 2/3 times 2/3 times 2/3. When you multiply fractions, you multiply numerators together for a product of 8 and denominators together for a denominator of 27. And then call it a day on that one. Cute. All right, moving on. Last problem of this type, we have -1/2 being multiplied 3 times over. For whatever reason, I am doing the expansion first, but the base here is indeed -1/2. Yes, the negative sign is part of the base itself, and the exponent is a 3. These 3 negative factors have the negative signs cancel out in pairs, so there is still a negative sign left over. So that indicates that the ultimate product is going to be negative, and it'll be a -1/8. Cool. So that's that. Moving on to the next thing. We're going to do the following problems below. If the problem is in fractional form, write the answer in fraction form. If the problem is decimal form, write the answer in decimal form. Okay, so more examples. Let's go ahead and just knock these out. And we can just plug these into our calculator. In fact, I recommend that we do that. This will be 4 multiplied 5 times over. What does my calculator say 4 to the 5th power gives me? 4 to the 5th power is 1,000. Oops, let me go ahead and go back to blue. Well, I'll change the color to like this dark purple. And I will erase this little guy. And we got dark purple now. It's 1024 is the result of 4 to the 5th power. So how am I getting that? It's 4 times 4 times 4 times 4 times 4. Oops, oops, oops. Go back. Don't do that. Why would you do that? Oh no, that's not the undo button. LOL. That rotates the item there. I'm gonna go ahead and erase this little bit. Yikes. Learn as you go, huh? All right, there we go. And like I said before, I typed this into my calculator, and we've got 1024. All right. And we'll go ahead and box that up in green for funsies. Okay. Moving on to 2.5 to the 3rd power. That's 2.5 times 2.5 times 2.5. You know what's up. I'm sure by now you've understood the drill, but I want to go through this with you also, just to make sure that we're all on the same page. And getting that into my calculator, I get 15.625. Next we have negative 7 to the 4th power, and negative 7 is indeed the base, so it gets multiplied 4 times over, like so. And what does my calculator say will be the resulting value there? 2,401, and it is indeed positive. How do I know that? Because there are 4 negative signs and they cancel out in pairs. So there will be no negative signs left over. So I know that my final answer will be a positive 2,401. Oops. Also, I've been meaning to box my final answers as I go. I think that's a good rule of thumb, a good habit to get into. Okay, now here we should have, let's see, something different at least going on in the expansion. Yes, 7 gets raised to the 4th power, and then the whole thing is negated. Okay, so we're going to have the same raw number of 2,401, but instead of being positive like it was over here because all of these 4 negative signs canceled out, we only have 1 negative sign here. So this will yield negative 2,401. Okay, hopefully everyone can see the distinction there, and it's well understood how that came about. And if not, please ask. All right, fractions, they're no different. If the base is 3/5, then 3/5 gets multiplied out however many times is indicated by the exponent. In this case, it'll be 4 times. Okay, so that'll yield an 81 in the numerator, because I remember from a previous problem that 3 to the 4th power was 81. And then what's 5 to the 4th power? Well, that's 25 times 25. I feel like I should know that one off the top of my head, but I'll just go ahead. It's 625. Dunzo on that one. Okay, and then one more of this ilk, and then we'll move on to another type of problem. Here we've got negative 3/4, not fifths, excuse me. And we got to do it 5 times over. And notice that all of these factors are individually negative. They will cancel out in pairs, but since there's an odd number of them, there's going to be an extra one left over. So here, these cancel out, but we're left with this one. So ultimately the final answer will indeed be negative. Oh, I'm sorry. Look, I put 4 here and they put 5 all the way across there. Did you guys notice that? A little bit of an error on my part. Let me quickly correct that. Luckily, it's an easy fix using this stylus. Whew, crisis averted. Okay, so 3 to the 5th power will be 81 times another factor of 3. Let me just go ahead and type that into my calculator to get that value. That'll be 243. What's 4 to the 5th power? I feel like we did that one earlier. 1024. All right, and it's going to be negative. Let's not forget the negative sign, so I'll put that out in front. And let's go ahead and box that answer and call it done. Lovely. Okay, moving on to the next set of problems. We're given something different and we want to do something different to represent what's going on here. So let me get a new color going on. We'll go magenta with it. So for each of the following, write in exponential form and then evaluate. So this has 4 factors of 6. So I can rewrite that using exponential form as 6 to the 4th power. And then what is 6 to the 4th power? Well, let's ask the calculator. 6 to the 4th power, 1296. Alrighty, and let's see what would be a good accent color for that. Let's go this pale yellow. Pretty. Okay, back to magenta. Here we clearly have 4.3 being multiplied 3 times over. Now that's not to say that the 3 exponent is only being imposed on the decimal, it's being imposed on the entire number 4.3, okay? And if you feel compelled, because the individual factors are encapsulated with parentheses, you can have that notation transfer over to your representation of the exponential notation there. 4.3 though to the 3rd power is going to yield 79.507. Okay, great. Moving on. Next, I'm looking at the negative signed one with the 1, 2, 3, 4, 5, 6 factors of 8, and it will be negative with no parentheses, okay? Which will yield a negative final answer. What's 8 to the 6th power going to give me? Something big. Oh, Lord, yes. Actually, let me go ahead and erase this because I need to put my answer underneath what's going on here. That'll be negative 2062. 262,000, that is, 144. All right. And again, I'm getting these numbers with my calculator. It's okay to use your calculator for part of this calculation, but you want to make sure you understand how we're getting there. So this has factors of -2, 6 of them total, being repeated. So that means the -2 needs to be inside of the parentheses. Okay, and having 6 factors of -2 is going to have all of the negative signs eventually canceling out. So cancel them out in pairs. There's 1 pair, 2 pairs, 3 pairs. Are there any negative signs left over? Nope. So that means that the entire product ends up being positive in the end. So what are we going to get when we take 2 to the 6th power? Or rather, -2 to the 6th power. It'll be the same. As if the 2 was, as if the 2 was positive. That'll be 64. That one's donezo. 2 more of this type and then we'll be done. That'll yield a 1/4 quantity to the 4th power. And I believe that'll be 1 over 128. I'm going to confirm that though with my calculator. 4 to the 4th power. oh, sorry, 256. Yikes. Because if it was 4 to the, hold on. Yeah, 256. It's 4 to the third power is 64 times another factor 4. Oh, sorry. Yeah. Let me erase that. It was 256. My bad. Okay, there we go. This last problem in this set, we're going to have negative 2/7 in parentheses raised to the third power because that's the item that gets repeated with the negative sign and all. So that will yield a negative, right? How do we know it's negative? It's going to the original problem. We can cancel out the negative signs 2 at a time, but there's still going to be 1 left over. So that'll transfer over to the final answer as well. That'll be an 8 in the numerator. And what is 7 to the third power? I want to say it's 434. But you know what? This warrants checking. 343. Close, but no cigar. Glad I checked. All right. There we go. Cool. So that's lots of practice on dealing with exponents here. Oh, and then there's still more. Check this out. Pay close attention on how to handle negatives. Yeah. Multiplication, exponent. Okay, great. So let's go ahead and rewrite this one. Let's get a new color scheme. Let's go green with it. This one is -6 times -6. That gives you a positive 36. How do I know? Well, these negative signs cancel each other out now, don't they? And the -6 is the thing that needs to be repeated because we have that negative sign inside of the parentheses. Whereas in this similar problem, right? Similar but different, we have the 6 being repeated, and then the negative sign just kind of comes along for the ride, just kind of sits out in front. So that will yield -36 as its ultimate value. Okay. Next one, we have negative 8 to the third, but the 8 to the third power needs to be dealt with individually, or first rather. Here's 8 to the third power, and here it is being negative. Boom, right? And then that'll give you negative, what's 8 to the third power? That's going to be 64 times 8. Don't know that off the top of my head, but 512. It's going to be the final answer on that one, the ultimate value. Oop. And then differently as far as the expansion is concerned is how we're going to write out the next one, because the negative sign is inside the parentheses, so it's part of the base that gets repeated. Cool. So we're going to still get 512, and yes, it's still going to be negative by virtue of the fact that these negative signs, 2 of them will cancel out, but we'll still have 1 left over. Okay. So last couple of them here. This will be, hold on, let me cancel out some negative signs. 1, 2, 3, 4. The ultimate product here in the end will be positive, and it'll be a 1 in the numerator. What's 4 to the fourth power? I think it was 256. Is that what we said earlier? Let me double check. Yep, 256. And it is indeed positive. Lovely. Now here we have negative 2/7, and you could put it in parentheses or not, being raised to the third power, but the fact that the negative sign is outside of the parentheses, or there could be no parentheses at all, and that would be an equivalent statement here. That means that we're not going to repeat the negative sign inside the parentheses like we see the original problem having, and we know that ultimately the final answer is indeed going to be negative. It'll be negative 343 in the denominator and 8 in the numerator, if I am not mistaken. Okay. Gorgeous. Let's go ahead and make sure all of the answers got boxed up, and we're ready to move on. Okay, now we want to drive home this idea and explain the difference between -7 as the base raised to the fourth power and -7 to the fourth power. 7 to the fourth power being its own entity and the negative sign just out in front. You can say the following. When parentheses are present and the base is negative, then the negative sign gets repeated. In the expansion. Thus, -7 to the fourth power equals -7 times -7 times -7 times -7 again. Oh, what's -7 to the fourth power? Big old number, 2,401. I believe we did that one actually earlier. And it'll be positive. Right? Because, and I'll go ahead and just along the way do boop, 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 boop. Whereas, so I'll continue my thought, and -7 to the fourth is just -7, 7, 7, 7, which equals -2,401. Ooh. Lovely. And there we go. That'll do. There's a little bit more than probably you need to. But there you go. That'll do as far as explanation is concerned between the difference between a base of -7 versus a base of 7 in which the exponential expression is negative. Okay? Cool, cool, cool. Now we're going to dive into order of operations. This is going to be helpful in simplifying expressions that have multiple operations. We want to know in which order to perform the operations. PEMDAS is here for us. This is going to be the thing that we rely on. If you are not a fan of PEMDAS, I am right there with you. I kind of think PEMDAS deserves to go in the trash myself, but that's because I've been burned in the past by the M and the D, the A and the S. Like the M coming before D in PEMDAS has erroneously had me believe that multiplication always comes before division, but what's actually happening, and this is specified in step 3 here in the write-up, that multiplication and division are actually on the same step, the same height in the hierarchy. You just do whichever comes first from left to right. And the same thing is true for addition and subtraction. Okay? So these ones are the tricky ones to look out for. If you want an alternative, I offer GEMA. Okay? Which is to say, GEMA is grouping symbols. E is exponents, same as the other, PEMDAS and other acronyms. M is multiplication and division. Like there's no separate letter to indicate that they are on the same tier, whichever comes first from left to right. And then A is addition, subtraction. Again, whichever comes first from left to right. Cool. So let's keep this in mind as we tackle the next series of examples here. Let me go ahead and change the color scheme here for fun. Let's go with a, what seems good? Let's go with this teal color. Let's evaluate each of the following problems. This first one, we want to go inside of the grouping symbol first. So I usually underline the thing that I'm about to do, and then everything else just comes along for the ride. What's 8 minus 3? It's 5. And then next we will go ahead and multiply and get a final answer of 10. Okay, and I'll box up on my final answers once I'm done here. Next we will go inside the grouping symbol for a 2 times 5 to the second power. Next we want to deal with the exponent. That'll be 5 squared is going to be 25. Right? In this step we would not multiply the 2 and the 5. Nope, there's an exponent that needs to be dealt with first. So now 2 times 25 will give 50 as our final answer there. Oh, I guess I'll just box them up in teal, whatever. Cool, cool, cool. Let's go ahead and we can do grouping symbols if there's 2 of them at the same time. We could do them at the same time if we want to. Look at how within these 2 sets of parentheses the fractions have the same denominator. That is delightful. We have 5/7 here, and then we're going to multiply that by 12/5 there. And then notice that we have some slashing to do. That's so fun. Common factors diagonally across the way can be slashed. If we had common factors here, we could slash them away as well, but we don't, so let's just go ahead and move on with the rest of the problem. Multiplying the factors that are left, numerators to numerators, we get 12 over 7. And you can go ahead and leave that as your final answer. There's no need for you to turn that into a mixed number or decimal, in my opinion. Next, over here we have 2 different sets of grouping symbols. Let's do the parentheses first, or the innermost grouping, and leave everything else for later steps. 8 minus 10 is going to yield a -2. Here we are subtracting a negative, which is equivalent to adding the opposite, right? Hopefully everyone knows what to do here, and if you need a little bit more explanation, I'm happy to give it. Otherwise, that was probably enough to get you refreshed on that. So that's actually 12 plus 2, which is indeed 14. And at this point, we really don't need the brackets anymore. 12 plus 2 is just going to give us that 14, and that's our final answer. Okay, last one in this set. Let's go for the innermost grouping. 3 plus 2 is going to yield 5. And we can drop, we can drop the parentheses at that point. And it's still, though, all ultimately raised to the second power. We still have one more operation to perform inside of a grouping symbol, so let's do that first. That'll yield 8 minus 5 is 3. At this point we should deal with the exponential expression. So that'll be 2 times 9, because 3 squared is 9. And then lastly, of course, there's only one operation left, the multiplication. And that'll yield a final answer of 18. Cool, cool, cool. Alright, now with this next exercise, we want to consider the following expression: 3 times 6 minus 8 plus 2. What is the correct order of operations? Notice that this question is not asking you to perform the operations in the right order in order to find a final answer. They're just like, in what order do you do them correctly? Well, first you would multiply, right? Because what are all of the operations here? There's multiplication, subtraction, and addition. There's a clear winner as far as which one is done first among those 3, and it's multiplication. Alright, then you would subtract. I know, some people might be like, wait, PEMDAS says I subtract after I add all the time. No, addition is always in the same level as subtraction, so you do whichever comes first from left to right. In this case it'll be subtraction and then addition. Okay, great. Moving on. Simplify. Okay, so more examples here. For number 1 in this set, we're going to multiply first to get 20 minus 7 plus 9. So let's do this correct ordering in action. The next thing we're going to do is subtract. 20 minus 7 gives 13, plus 9 is, if I'm not mistaken, 22. Final answer. All right, number 2. There's an innermost grouping symbol that we want to tackle first. That's going to be this 5 minus 8 is going to yield a negative 3. Okay, the next thing we want to do here is deal with the exponent inside of this remaining grouping symbol. And notice that everything else just kind of comes along for the ride. I'm not about to do more than one step at a time unless I feel comfortable with it. Okay, most of the time I'm not comfortable doing more than one step at a time because it can be unclear on what you should be doing next. So this negative 3, since it's in parentheses and got squared, it's like negative 3 times negative 3, and that's how I get a positive 9 here. Now I multiply. 2 times, 36 minus 10. And then that'll be 2 times, what's 36 minus 10? 26. And then that'll give me 52, if I'm not mistaken. Cool. Moving on to number 3. Ooh, we got some fractions going on here. So what's cool about a fraction or exponential expressions, which is technically what we have in 3, is that you can perform one operation per area, per one for the numerator and one for the denominator. Now here we only have operations happening in the numerator. The denominator is already simplified down to just 8. So there's nothing to do in the denominator. This isn't a good example of that point, but there are examples coming up. Look at number 6, where we'll be able to do that. So let's first deal with the exponential expression in the numerator. 2 squared becomes 4. And then let's perform the subtraction, and we'll get 16 over 8. Now, can 16 over 8 be reduced? Yes. So go ahead and reduce it, and you should get a final answer of 2. 2 over 1, you know, but any fraction over a 1 is going to be just a whole number or an integer, and that's how you should display it. Okay, looking at number 4, the first operation we should perform here is the division. That'll yield 15 minus, what's 16 divided, or 18 divided by 6? That's 3 plus 5. So notice I didn't say what's negative 18 divided by 6, okay? This symbol right here, I am treating it like subtraction, and subtraction is something that you don't do until all of the multiplication and divisions are done first, okay? Now here at this stage we have subtraction and addition. Let's do them in that order from left to right. 15 minus 3 is going to yield 12. Now we need to add 5 to it, and we will get 17 as our final answer. Moving on to number 5. The first item that we want to do is this multiplication here, because among all of the operations present, it's going to have the highest ranking. And I mean, among multiplication division, multiplication came first from left to right, so that's why I'm doing it first. Not because in PEMDAS M comes before D. That's not why I'm doing this. What's 6 times 2, everybody? It's 12. Okay, so the next thing that I'll do is 12 divided by 4, not negative 12 divided by 4, because this is subtraction, okay? 4 plus 8 minus 12 divided by 3, or 4 is a 3, plus 1. Now I'll do the addition. 12 minus 3 plus 1. Now I'll do 12 minus 3 is, sorry, that'll be 9. Plus 1 is 10. Yeah, okay. One more in this set. Lots of examples for you. I hope these are helpful. Now this is an instance in which we have a rational expression, and there's several operations going on in both numerator and denominator. I will do one for each. So in the numerator, I'll go ahead and do the grouping symbol first. In the denominator, the highest ranking operation is the exponent, so I'll do those both at the same time. So I'll have negative 3 to the second power plus 7 times negative 2, because that's the result of 1 minus 3. And then it'll be 3 times 2 to the third power is 8 plus 6. Okay, now go ahead and again do the highest ranking operation in both the numerator, which in this case will be the exponent, and in the denominator it'll be the multiplication. You can do them both at the same time. So that'll get negative 3 to the second power will yield a positive 9 plus 7 times negative 2. Here I'll have 24 plus 6. There's only one last operation in the denominator, so obviously I'm going to do that. And then here it's multiplication first. That'll yield 9 plus negative 14, right? Because 7 times negative 2 gives the negative 14, and I'm choosing to keep it in parentheses in order to, keep it straight that I'm adding a negative number. And then down below it looks like it'll be 30. Okay, now we can add these two integers. 9 plus negative 14 will be negative 5 over 30. And sorry, let me give myself some more room here. That's negative 5 over 30. I can reduce that to negative 1/6. I'm going to pull the negative sign out in front. And really, I'm just recognizing that I have a common factor of 5. It divides itself the once, it divides the 36 times. And I want to maintain that this is a negative fraction. So I pulled it out in front, and I've got 1/6 as the remaining parts. Okay, cool, cool, cool. What's next? We have some word problems that we want to tackle, and mostly it's going to be relying heavily on your calculator. So if we want to talk about calculator use during the Zoom meeting, I think that might be appropriate. But for all intents and purposes, let me just go ahead and show you what your final costs would be and the appropriate sentence that answers the question. So the example for this first one is as follows. The total cost of a new textbook is $125 plus sales tax of 9.25%. So notice that the 9.25% is coming to you in the form of a decimal. That's something that we're going to get really in depth about. Okay, this is the same as that. Cool, cool, cool. And so in order to find the sales tax or the total price that you pay when you go to the register, you need to add the 9.25% of that price to the original price of $125. So let me go ahead and calculate this for you. 0.925 times 125. Hold on, or I could do this another way. 1.00925 times, oops, too many. 1.0. Sorry, you're overhearing my calculations here. That'll give you 100, and we're going to write this to the nearest cent. So you should get $136.56. So the amount we pay is $136.56. Cool. I can leave it at that. Let's go ahead and do the same thing for this next problem. So go ahead and type this expression into your calculator. I would start with the multiplication first and then add the 725 to it later. Or you could do the shortcut that I'll talk about of taking a factor of 1.0855 and multiplying that by 725. We can talk about that in class if we want. And that'll yield $786.99 if you round to the nearest hundredth, or to the nearest cent, to two decimal places rather. So the price of the bike, or the amount we pay for the bike, is $786.99. All right. A couple more of this ilk. We have some more complicated expressions to evaluate. So this will require more complex use of your calculator. So I'll Be sure to demonstrate this in class if you want. Otherwise, I just want you to be able to check your answers with me. I would start with the 0.12 divided by 12, and you'll get 0.01. You want to add that to 1, and then raise that to the third power. And you'll get 1.030301. That needs to be multiplied by the 2000. So really, this whole thing right here is an exercise in using your calculator correctly, which is something that's hard for me to describe in this particular type of lecture video. So, like I said, we can go over it in our class discussion. We'll say the amount in our account is $2,060.60. So that's when you started off your account with $2,000 and it earns 12% compounded monthly interest. Okay, cool. Now, all of those things that were mentioned are things that we'll get into more detail, like a compounding interest type things, and then also this one when we're talking about cost of material needed. It's good for us to look at these word problems and get to know them, but ultimately I just want us to be able to use our calculators effectively with order of operations. So here I would take probably well, 550 or $5.50 and multiply it by 2. I know that that's going to be $11. Like we could do that. 250 multiplied by 2 is going to be 5. So these things can be multiplied pretty easily, like by hand or in your mind. So 11 times 200 would be 2200, right? 2200. And this 5 times the 300 would be 1500 or 1500. So what's 2200 plus 1500? 3700. And it's in dollars. And what was this trying to determine? The cost of the fence. Oh, no, 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 no. The cost of the fence. So notice that each of these required a full English language sentence to wrap it up. Write your sentence, your answer in the form of a sentence is something we definitely want to get into the habit of. Cool, guys. That's it for today. Let's go ahead and spend some class time discussing what we have just seen and give me your questions. Thanks a lot, guys.